Hello viewers. So today I am going to start a new chapter for you, that is chapter number 2 called Units and Dimensions. Okay, so in this chapter we are going to study about physical quantities, how many types of physical quantities we have, what are physical quantities, and we will discuss about dimensional formula, about dimensions, applications. So many things we are going to study here, okay, about significant figures and all. Okay, so first let me tell you about physical quantity. So what is a physical quantity? See, I have written a definition of physical quantity here. Okay, so all quantities which can be measured directly or indirectly and in terms of which basics of physics can be expressed are called physical quantities. So here ಯಾವ ಕ್ವಾಂಟಿಟಿನ ನೀವು ಮೆಜರ್ ಮಾಡ್ತಿರೋ ಅಂಥ ಕ್ವಾಂಟಿಟೀಸನ್ನು ನಾವು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ನೋಡಿ, I have told you all quantities which can be measured directly or indirectly. ಸೊ ನಾವು ಡೈರೆಕ್ಟಾಗಿಯೂ ಮೆಷರ್ ಮಾಡ್ಬೋದು ಆ್ಯಸ್ ವೆಲ್ ಆಸ್ ಇಂಡೈರೆಕ್ಟಾಗೂ ಕೂಡ ಮೆಷರ್ ಮಾಡ್ಬೋದು. ಆ್ಯಂಡ್ ಆ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಬೇಸಿಕ್ಸ್ ಆಫ್ ಫಿಸಿಕ್ಸ್ ಕೂಡ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೋದು. ಸೊ ದಿಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಅ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ. ಓಕೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಮಾಸ್ is a physical quantity, length is a physical quantity. Why I am saying this as a physical quantity? Because for mass we usually represent mass in terms of kg, right? Ishta mass ide, either I have to represent in terms of kg or I have to represent in terms of gram, right? Suppose if I go to shop to buy a sugar, okay, we'll tell the shopkeeper to give 1 kg sugar for me. So then on simply ನನಗೆ ಪ್ಯಾಕ್ ಮಾಡಿ 1 kg sugar ಅಂತ ತಗೊಳ್ಳಿ ಅಂತ ಕೊಡಲ್ಲ. So first he'll going to measure the quantity of sugar. So ಎಷ್ಟು ಕ್ವಾಂಟಿಟಿ ಇದೆ ಅನ್ನೋದು ಅವನು ಮೆಷರ್ ಮಾಡ್ತಾನೆ. After measuring the quantity or after measuring the sugar which was in a packet, then he'll going to hand over to me. ಸೊ ಅಲ್ಲಿ ಮೆಷರ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಹಿ ಹ್ಯಾಸ್ ಟು ಯೂಸ್ ಸಮ್ ವೇಯಿಂಗ್ ಬ್ಯಾಲೆನ್ಸ್. ಸೊ ಅವನ ಹತ್ರ ವೆಯ್ಟ್ ಬ್ಯಾಲೆನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಆ ವೆಯ್ಟ್ ಬ್ಯಾಲೆನ್ಸ್ ತೊಗೊಂಡು ಅವನೇನು ಮಾಡ್ತಾನೆ, ಮೆಷರ್ ಮಾಡ್ತಾನೆ. ಸೊ ಅಲ್ಲಿ ಯೂಶ್ವಲಿ ನೀವು ಕೂಡ ನೋಡಿರ್ತೀರ, ತಕ್ಕಡಿ ಅನ್ನೋದು ಕೂಡ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇಟ್ ಕಂಟೈನ್ಸ್ 2 plates. ಸೊ ಒಂದು ಪ್ಲೇಟಲ್ಲಿ ಒಂದು 1 kg ಬಟ್ ಹಾಕಿರ್ತಾನೆ, ಇನ್ನೊಂದು ಪ್ಲೇಟಲ್ಲಿ ಸೊ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ಶುಗರ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾನೆ. ಸೊ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋದಂಗೆ ಅಲ್ಲೇನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಬಿಕಮ್ಸ್ ಬ್ಯಾಲೆನ್ಸ್. ಸೊ ವೆನ್ ಇಟ್ ಬಿಕಮ್ಸ್ ಬ್ಯಾಲೆನ್ಸ್, ಸೊ ಆವಾಗ ಹಿ ವಿಲ್ ಹ್ಯಾಂಡ್ ಓವರ್ ದ ಅಮೌಂಟ್ ಆಫ್ ಆ್ಯಂಡ್ ಶುಗರ್, ರೈಟ್? ಸೊ ಆ ಮೆಷರ್ಮೆಂಟನ್ನು ನಾವು ಡೈರೆಕ್ಟ್ ಮೆಷರ್ಮೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಸಚ್ ಮೆಷರ್ಮೆಂಟ್ಸ್ ಆರ್ ಸೆಟ್ ಟು ಬಿ ಡೈರೆಕ್ಟ್ ಮೆಷರ್ಮೆಂಟ್. ಅದೇ ನಾನು ಒಂದು ಬಟ್ಟೆ ಅಂಗಡಿಗೆ ಹೋಗಿದ್ದೀನಿ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಐ ವಾಂಟ್ ಟು ಬೈ 2 meter ಕ್ಲಾತ್ ಫಾರ್ ಮೀ, ಯೂನಿಫಾರ್ಮ್ ಕ್ಲಾತನ್ನು ತೊಗೊಳಕ್ಕೆ ಹೋಗಿದ್ದೀನಿ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಸೊ ಆ 2 meter ಕ್ಲಾತ್ ನಾನು ಬೈ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ವಿಲ್ ಟೆಲ್ ದೆಮ್ ಟು ಗಿವ್ 2 meter ಕ್ಲಾತ್. ಸೊ ದೆನ್ ದೇ ವಿಲ್ ಮೇಕ್ ಯೂಸ್ ಆಫ್ ಅ ಮೆಷರಿಂಗ್ ಸ್ಕೇಲ್. Usually shopkeeper will have a standard scale, 1 meter scale. ಸೊ ಆ 1 meter ಮೆಷರಿಂಗ್ ಸ್ಕೇಲಿಂದ ಅವರು ಕ್ಲಾತನ್ನ ಏನು ಮಾಡ್ತಾರೆ, ಮೆಷರ್ ಮಾಡ್ತಾರೆ. 1 meter ದೆನ್ ಆ 2 meter ಕ್ಲಾತನ್ನು ಅವರು ಪ್ಯಾಕ್ ಮಾಡಿ ಕೊಡ್ತಾರೆ. ಸೊ ಹಿಯರ್ ದೇ ಆರ್ ಮೆಷರಿಂಗ್ ಡಿರೆಕ್ಟ್ಲಿ. ಸಚ್ ಮೆಷರ್ಮೆಂಟ್ಸ್ ಆರ್ ಸೆಟ್ ಟು ಬಿ ಡೈರೆಕ್ಟ್ ಮೆಷರ್ಮೆಂಟ್ಸ್. ಸೊ ಯಾವ ಕ್ವಾಂಟಿಟಿನ ನಾವು ಡೈರೆಕ್ಟಾಗಿ ಮೆಷರ್ ಮಾಡ್ತಾ ಇದ್ದೀವೋ ಅಂಥ ಮೆಷರ್ಮೆಂಟ್ಸ್ನ ನಾವು ಡೈರೆಕ್ಟ್ ಮೆಷರ್ಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಯಾವ್ಯಾವ ಕ್ವಾಂಟಿಟೀಸನ್ನು ನಾವು ಡೈರೆಕ್ಟಾಗಿ ಮೆಷರ್ ಮಾಡ್ತಾ ಇದ್ದೀವೋ ಸೊ ದ್ಯಾಟ್ ಅದನ್ನು ನಾನು ಮೆಷರ್ಡ್ ಡಿರೆಕ್ಟ್ಲಿ ಅಂತ ಬರ್ತಿದ್ದೀನಿ. ಆರ್ ಇಂಡೈರೆಕ್ಟ್ಲಿ. ಸೊ ಇಂಡೈರೆಕ್ಟಾಗಿ ಮೆಷರ್ ಮಾಡುವಂಥ ಕ್ವಾಂಟಿಟೀಸ್ ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ, ಸಪೋಸ್ ಇಫ್ ಐ ವಾಂಟ್ ಟು ಫೈಂಡ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಫ್ರಮ್ ಅರ್ತ್ ಟು ಮೂನ್, ಆರ್ ಇಫ್ ಐ ವಾಂಟ್ ಟು ಫೈಂಡ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ 2 stars, or if I want to find the distance between 2 planets, then I have to measure indirectly. I can't able to measure the distance from earth to moon with the help of tape or scale. measure ಮಾಡಲಿಕ್ಕಾಗಲ್ಲ. So here I have to make use of some indirect measurements. So that indirect measurements are usually parallax method anta karitivi. Later you are going to study about parallax method. Okay. So here the quantities which can be measured, ಯಾವುದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಮೆಜರ್ ಮಾಡ್ತಾ ಇದೀವೋ ಅದನ್ನ ಡೈರೆಕ್ಟ್ ಮೆಜರ್ಮೆಂಟ್ ಅಂತ ಹೇಳ್ತೀರಾ, ಯಾವುದನ್ನ ನೀವು ಇಂಡೈರೆಕ್ಟ್ ಆಗಿ ಮೆಜರ್ ಮಾಡ್ತಾ ಇದ್ದೀರೋ ಸೊ ಅದು ಇಂಡೈರೆಕ್ಟ್ ಮೆಜರ್ಮೆಂಟ್ಸ್ ಆಗಿರುತ್ತೆ. Okay, and in terms of which basics of physics can be expressed. So here, what are the basics of physics? So you know, I think you have already studied about gravitational force of attraction, and hope you know the formula of gravitational force. So gravitational force is given by G into m1 m2 divided by r square. Okay, so this is the expression of gravitational force we have, where G represents the gravitational constant, m1 represents the mass of the first particle, and m2 represents the mass of second particle, and r represents the distance between the two particles, whereas F represents the force of attraction, right? See, we can measure this force in terms of Newton. So force is a measurable quantity. Force anna now measure ಮಾಡ್ತೀವಿ. In the same way, we'll measure the mass also. Mass can be measured in terms of kg or gram. And here distance, that is nothing but length between 2 points, that can also be measured, right? ಇಲ್ಲಿ ನಾವು r ಕೂಡ ಮೆಷರ್ ಮಾಡ್ಬೋದು, m1 ಕೂಡ ಮೆಷರ್ ಮಾಡ್ಬೋದು, f ಕೂಡ ಮೆಷರ್ ಮಾಡ್ಬೋದು. ಸೊ ಇದು ಎಲ್ಲ ನ್ಯೂಮರಿಕಲ್ ವ್ಯಾಲ್ಯೂಸ್ನ ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋದರೆ ವಿಲ್ ಗೆಟ್ ಗ್ರಾವಿಟೇಷನಲ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಸೊ ದಿಸ್ ಇಸ್ ಆ್ಯಕ್ಚುಲಿ ದ ಬೇಸಿಕ್ gravitational force expression, right? So by using physical quantities we can express basic laws of physics or basics of physics. Here I have another formula of force, that is mass into acceleration. See, mass is a measurable quantity. Mass can be measured in terms of kg, whereas acceleration is a measurable quantity again. So idunu kuda measure ಮಾಡಬಹುದು, idunu kuda measure ಮಾಡಬಹುದು, whereas I can measure force also. So ಈ force ಅನ್ನು ನಾನು measure ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಆಯ್ತಾ, by considering certain physical quantities. So idu kuda ನನಗೆ physical quantities. So basics of physics can be expressed by using physical quantities. Clear? So now you can understand the definition of physical quantity easily. So what is a physical quantity? All quantities which can be measured directly or indirectly, and in terms of which basics of physics can be expressed. Okay, so are called physical quantities. And I have told you we are having two types of physical quantities here. Okay, so what are the two types of physical quantities? So two types of physical quantities are, the first quantity is fundamental physical quantity. Fundamental physical quantity. So for physical quantity I'm just writing PQ here. And the second type of physical quantity we have is derived physical quantity. Okay, so now let me tell you what are fundamental physical quantities, or let me tell you the definition of fundamental physical quantity. So here fundamental physical quantities are nothing but independent physical quantities. They are completely independent physical quantities which do not depend upon one another. Okay, so ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಡಿಪೆಂಡ್ ಆಗಿರಲ್ಲ ಅಂತ ಕ್ವಾಂಟಿಟೀಸ್ ಅನ್ನು ನಾವು ಫಂಡಮೆಂಟಲ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಕರಿತೀವಿ. Okay, so fundamental physical quantities are independent physical quantities and they are not dependent upon other physical quantities. Clear? Okay, so what are fundamental physical quantities now? So basically we are having 7 fundamental physical quantities. So ಆ 7 fundamental physical quantities ಯಾವ್ದು ಅಂತ ಹೇಳಿದ್ರೆ, the first one is mass. So first one is Mass is a fundamental physical quantity, and the second one is length. It is a fundamental physical quantity, and third one is time. Fourth one is temperature, and fifth one is electric current, and sixth one is luminous intensity, and the seventh one is amount of substance. So these are 7 fundamental physical quantities we have: mass, length, time, temperature, electric current, luminous intensity, and amount of substance. Look here, mass can be represented in terms of kg or gram, whereas length can be measured in terms of meter or centimeter. They are completely independent. Here, if I want to measure the distance between any 2 points, then I have to find the length between 2 points. So it can be measured in terms of meter or centimeter. Time can be measured in terms of second or minute or hour. Temperature can be measured in terms of Kelvin or degree Celsius. Electric current can be measured in terms of milliampere, microampere or ampere. Whereas luminous intensity, candela, amount of substance can be measured in terms of mole. Okay, so these physical quantities are basically fundamental physical quantities, and they are independent of one another. They do not depend on each other. Okay, such physical quantities are said to be fundamental physical quantities. Clear? Now let me tell you what are derived physical quantities. So this is the second type in physical quantities, derived physical quantity. See here, the name itself indicates derived. We are deriving a physical quantity by using fundamental physical quantities. So now fundamental physical quantities na use ಮಾಡಿಕೊಂಡು ಬೇರೆ ಕ್ವಾಂಟಿಟಿನ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ನಾವು ಡಿರೈವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So such quantities are said to be derived physical quantities. Clear? So let me take one example here. So we'll consider speed. So how we are going to define speed? So you have already studied about this in your high school. Okay, speed can be defined as the ratio of distance and time taken. Distance divided by time will give you speed. So therefore, distance is nothing but length between 2 points. Okay, so length, distance is nothing but length here and divided by time. See, length and time are fundamental physical quantities. Both are fundamental physical quantities. See, we are deriving another quantity here, that is speed, by considering fundamental physical quantities. Clear? Let me take one more example, velocity. So velocity can be defined as displacement divided by time taken. Displacement divided by time. Displacement is nothing but length again. Displacement is nothing but length between 2 points but in a particular direction. See, here I have considered a distance. So I am telling you this is also a length between 2 points. Okay. Suppose the point A is in Shimoga and point B is in Sagar, then I have to consider the length between these 2 points. Simply we'll say the length between these two is in terms of kilometer. Okay, but here I can't represent the same in displacement here, because displacement has some direction. So for that I have to consider a car is moving from Shimoga to Sagar. See the direction. The car is moving from Shimoga to Sagar. So I have to represent this with a direction. Okay. Then we'll say the displacement here. Okay. Displacement has a direction, whereas distance doesn't have any direction. But displacement is also represents length between 2 points, but in a particular direction. So therefore displacement is nothing but length here and divided by time. See, again, length is a fundamental physical quantity, time is also a fundamental physical quantity. We are deriving velocity, which is a derived physical quantity, by using fundamental physical quantities. So fundamental physical quantities na use ಮಾಡಿಕೊಂಡು ನಾವು ಬೇರೆ ಕ್ವಾಂಟಿಟಿನ ಡಿರೈವ್ ಮಾಡ್ತಾ ಇದೀವಲ್ವಾ, such quantities are said to be derived physical quantities. Clear? So let me take one more example here. We'll consider acceleration. So how we are going to define acceleration here? So acceleration can be defined as velocity divided by time taken, right? So this is how we are going to define acceleration. So therefore velocity, just I have defined velocity for you. So velocity can be defined as displacement divided by time taken, right? Time taken, and one more time we have in the denominator, so I'm writing here. So therefore displacement can be measured in terms of centimeter or meter by considering that as length divided by time square. See, length is a fundamental physical quantity, time is also a fundamental physical quantity. So we are deriving another physical quantity called acceleration by using fundamental physical quantities. So the quantities which are derived from fundamental physical quantities are said to be derived physical quantities. Okay, is this clear for you? Okay, thank you.